This is Miss Germaine. I'm just coming at you with a video for this afternoon. So we're looking at, and we started in class, lesson number 5, equations and their graphs. So for our warm-up, we did a nice, easy, simple, quick warm-up. Which one of these doesn't belong and why? So you're looking at these different equations here, and you made the decision which one belonged, which one did not. Our learning targets for today were I can use graphing technology to graph linear equations and identify solutions to an equation. I understand how the coordinate points of the graph of a linear equation are related to the equation. And when given a graph of a linear equation, I can explain the meaning of the points on the graph in terms of the situation it represents. So first, we're using technology to graph linear equations and identify solutions. Then we're going to be able to use or understand how coordinates of the points, so the coordinate points of those points that fall on the line and are not on the line are related to those equations. Then when given a graph of a linear equation, we're explaining the meaning of the points on the graph in terms of the situation it represents. So we're sort of taking it and we're moving forward. So we're creating a graph. We're talking about different points on that coordinate grid. What do they represent in terms of the situation in the equation? And then we're talking about what it means in the context of the story. So this lesson is actually pretty cool because it really built upon each other and sort of got more complicated as we went through. So we were talking about snacks, buying them in bulk. We created an equation in standard form of 6a plus 9f is equal to 75. And we talked about what the variables represented, and then we solved for different values in this equation. So we found out how many pounds of figs would you buy if you bought 2 of 1 pound of figs, how many almonds would you buy? Then we built nicely on it, and we talked about these different points that sort of fell on this line and off this line and what they represented. So we found point A, C, and B. We listed out those coordinate pairs, x, comma, y, and then we talked about those points that fell on the line. What are they in the situation? They are solutions that would make the equation true, and these points that fall off our line, D and E, are coordinates, obviously, and what does it tell us? These ones do not fit in our equation. When we buy 1 pound of figs and 1 pound of almonds, that's not going to cost me a total of $75. When I buy 14 pounds of almonds and 0 pounds of figs, that's not going to cost me $74. So you're talking about points that fall on the line are solutions, points that are not on the line are not solutions. Then we sort of took it one step further, looking at a coordinate pair. What does it mean in the context of the story? And then we had to identify, was it a possible solution or not? Okay. From there, we looked at another point here, and then we talked about it in context. We were given this -1, 9. Is that a possible amount of figs and almonds that we could buy? No, it was not, because we bought -1 pound of figs. Like, that's literally not possible. So it is a solution in this equation, but in the context of the story, not going to happen. It's one of those constraints. They both got to be positive numbers. Okay. So now we're moving into today's. I know that was a little bit of an opening, but I really wanted to talk about and really hit again what we did in class, because this activity is going to build right on it. Okay. So you clicked on your cohort number with your video link, and we are given a scenario, and we need to write an equation that represents the relationship between the amount of dollars in their account and the number of weeks in the weeks of savings. So a student has a savings account with $475 in it. She deposits $125 each week. Her goal is to have $7,000. So Let's think. We have to write an equation that represents the relationship between the amount in her account and the number of weeks of her savings. So I want you to take, I'm going to grab my timer. I want you to take 2 minutes right now to write an equation and identify what each of these variables would mean. If you finish early, I want you to look at B and C as well. How much would she have after 3 weeks, and how long would it take her to get to $1,350? I'm going to grab my timer and we're going to get started. Here we go. Think about this $7,000. Is this $7,000 going to play a part in this equation? Yes or no, as you're thinking and you're writing. Okay, we have another minute and 10 seconds to write this equation, identify what your variables are going to be and what they represent, and then take a look at B and C if you finish early. Okay, we're going to take another 42 seconds. Okay, another 15. 5. Okay. So first thing we're going to do here is we're going to identify some variables. And I want to sort of use some variables that pertain to the things that they're talking about. So we can use X and Y, but I want to be a little bit more creative and thoughtful in the way that we choose these variables. So we're talking about, we're going to have variables that represent the total amount in her savings account. So we could use A, or we could use T, we could use A, and that would represent the total amount of money in her account. Okay, so we're talking about the total amount of money in the account. Okay, that's the first variable. Our second variable, we're talking about how many weeks she's throwing money or putting money into that account, right? So we could use, for our second variable, we could use this variable of W, right? And that represents the number of weeks she's saving, right? So T represents the total amount of money in the account. W represents the number of weeks. So if I were to write an equation for this guy, I would say T, or that total amount, is equal to that variable W times how much is she putting per paycheck? 125W. You could put that multiplication sign in there if you want, plus that original 475 that she had in the account. So plus that original 475. Okay. Now we need to identify how much money she would have after 3 weeks. So that one we're going to substitute W in for, we have the number of weeks. So we're going to substitute that in for W, and we'll say T equals 125 times 3 plus 475. So then we'll say, hit enter here, and we'll say to ourselves that's equal to, T is equal to 375 plus 475. And that will be, T is equal to, our total is equal to $850. And we have to give it a label of dollars. Okay, so if you're in your textbook, I know that this is in slightly different order, but that's okay. So then, now we're looking at this next piece, and it's how long will it take for her to have 1,350 in her account. So now we're solving for that W, so that W is not going to be the variable that we have left. So we're going to plug 1,350 in for T. And that will be equal to 1,350 equals 125 times T plus 475. We will be left with, sorry, Mr. Man just got confused. 1,350 is equal to 125T. We're going to subtract 475 from each side, so we'll be left, so we're going to say plus, or we're going to say minus 475. We're going to be left with 1,350 is equal, no, Miss Shireen. 1,350 minus 475 is equal to 875. 875 is equal to 125T. Isolate by dividing by 125. And we're going to be left with 7. 7 is equal to the number of weeks. So it's going to take her 7 weeks to make $1,350. Okay, so now a student has a savings account with $450 in it. Now we have to answer this question of graph this equation using the graphing technology. Mark the points on the graph that represent the amount of after 3 weeks. In the week she has 1,350. Write down the coordinates. The tech tool is on slide number 12. And we're going to insert a picture of it on slide 12. So I want you to skip and scoot down to slide number 12. Click on that image right here. So it says the graph. Graph the equation from slide number 10. Using this tool, click the image to open the link. Once you open it, graph the equation. Take a screenshot, insert the graph here, label the 2 coordinates, and tell them and to tell you in the using the text box below. So you're going to click on that picture. You're going to open up the Desmos. Okay. And from there, you need to type that equation in that we wrote here. And our equation is 125 times W plus 475. So you're going to come to this Desmos here, and you're going to come into this spot where the green squiggly is, right? And you're going to delete it, and you're going to type in Y is equal to 125 X plus 475, okay? And you're going to have a graph here, okay? You're going to want to, and it has labels of weeks and dollars. You're going to, I would say you probably want to zoom it in a little bit, okay? And drag it down a little bit so that we can sort of see, and we'll be good there. So now we want to take a screenshot. So remember, that's Control Shift and then that box above the D. I mean the 6, and get that box in there right there. It just saved my screenshot. I'm going to copy it to clipboard so I can just come back onto this next slide right here and paste it in. Okay, so we have these points actually already labeled for us because it's kind of a pro like that, kind of cool. And you pasted it in. Now we need to go back to slide number 11 to answer that question. Okay, so how long will it take her to reach her goal? Remember, what was our goal if we think back? Her goal is to save $7,000. So when we come back to this graph, we're going to look for $7,000 on which axis, my X or my Y. Oh my goodness, you're right. It's the Y. And so when we're looking for that $7,000 value, we're going to have to scroll it out. And we see this orange line that's actually graphed on here. So we have to take a screenshot with this piece so that we can know exactly where it hits. So if we go Control Shift and then that box above that button above the 6, I'm going to take a screenshot of this whole graph here so that I can see the coordinates and where they fall. And I'm going to copy it to clipboard. I'm going to come back to this slide right here, and I'm going to paste it in. Okay? So I have this in here now. It's kind of, I'm going to make these directions a little bit better. So then it asks us, how long is it going to take her to reach her goal? How many weeks is it going to take her to reach that $7,000? I want you to take 10 seconds right now to write that answer in this box right here, giving me a label for your answer. How many weeks is it going to take her? It will take her, if we look really closely at that graph, it's 7,000, 7,000 was that first number, 52.4. So how many weeks is it going to take her? We're not talking about 0.2 weeks. It's going to take her 53 weeks to save $7,000. Okay? So it's going to take her 53 weeks to save $7,000. Okay? So we inserted our graph right here. We actually didn't even need these boxes because it gave us some help there. So now if we look at this next piece here, it's talking about a 450-gallon tank full of water is draining at a rate of 20 gallons per minute. I need you to write an equation that represents the relationship between the gallons of water in the tank and the minutes the tank has been draining. Okay, so I want you to take 2 minutes right now. I'm going to start my timer. And I want you to take 2 minutes right now to start to write an equation and naming your variables, and then find these two solutions right here. Think about what that word draining means in terms of operations you're going to be doing. Okay, we're taking another minute and 30 seconds. We have 1 more minute. Remembering that if you finish writing the equation and identifying the variables, I would love for you to tell me and answer B and C for me as well. Okay, we're taking another 43 seconds. Okay, 7 more seconds. Here we go. And here we go. Let's take a look. Okay, so now we're talking about a tank that is draining. So let's talk about some variables here. So we're talking about the number of minutes that the tank has been draining. So a good variable for that might be M, right? So M represents the number of minutes it's been draining, right? And then, so M is the number of minutes it's been draining. And then the other thing is talking about like the gallons left. So that another good variable for that one might be G, the number of gallons left. Okay, that might be a good variable for that one. Then, now we need to write the equation. So the number of gallons that are left, G, is equal to, so it starts with a 450. So we're going to be, from that 450, we're going to be subtracting 20 each gallon. So we might want to put that y-intercept first. So we might be good to say 450 minus 20 m, right? If you wrote it this way, G is equal to negative 20 m. One second, I missed my 20. Negative 20 m plus 450. That means the same thing, and it is 100% correct. I just sort of thought about it logically and put it in the order that sort of it made more sense, right? So I didn't need to write it as a negative 20. I could just say minus 20 times the number of minutes that it's draining. So I have both of these equations. They mean the exact same thing. So now, how many gallons will be in the tank after 7 minutes? So that means I need to take 7 and plug it in for which variable? M stands for minutes, so I'm going to plug 7 in for M. 7 in for M. So that's going to look like this. Okay, so from there, I'm going to say G is equal to 450 minus 20 times 7. So G is equal to 450 minus 20 times 7 is 140. Okay, G is equal to 450. Mr. Man, you got this. Minus 140 is equal to 310. G is equal to 310. What is going to be our label on that? Gallons. Okay? Gallons, not gala. So now we're going to do the same thing, but this time we need to figure out how long it's going to take the tank to have 200 gallons. So now we're going to plug 200 in for G. Gallons stands for G. So it would be 200 is equal to 450 minus 20 times T. M. Okay? Then from each side we're going to subtract 450. Subtract 450, 200 minus 450 is going to be negative 250 is equal to negative 20m. Divide by 20 on each side. Divide by negative 20 on each side. And we're left with a positive 12.5 is equal to m. So it's going to take 12.5 or 12 and a half minutes. Okay? So from there, we're going to take a look at the next piece of this, slide number 14. Okay? So slide number 14, we're dealing the same thing we did last time. We have to graph it using this on slide number 15. And we're going to insert a picture of it on slide number 15. Okay, and how long will it take for the tank to be empty? So let's take a look at what we have to do here. So we're coming to slide number 15 and clicking on that photo to open up the link. We're going to wait for Desmos to load for us. And we're going to come into this line right here. We're going to write our equation. We're going to say y is equal to y is equal to 450 minus 20x, and it's going to have our equation line. We're going to have to zoom it in a little bit, sort of reposition it a little bit, and we're going to see where it hits. So how long is it going to take for, so let's actually zoom it out and let's take a screenshot of this graph right here. So let's hit that Control Shift and then that box above the 6. Make sure that you cut it so that you have all of it in here. You copy it to your clipboard. You come back to your slideshow. on slide number 15, you're going to paste that picture in, and you're going to be ready to go. Okay, so then from there, we're going to answer some questions on slide number 14. So it says, how long will it take the tank to be empty? So now we're going to look back at our graph, and we need to think about what point would represent on our graph when the tank would be empty. So if we're looking at when that tank is going to be empty, it's going to be when that equation line hits the y-axis. So when I come over here, if I sort of take my pointer and I zoom it in, if I zoom it in enough and you click that point where it hits the y-axis here, it's going to hit the y-axis at 22.5, 0. So how many minutes is it going to take that tank to be completely empty? It's going to take it, if you put your finger over it, it's going to be 22.5. So I want you to put your finger over that point so that the coordinate pair is on there when you go to hit Control, Shift, and then the button above the the 6. And then you sort of just take a nice little screenshot of it and copy it to clipboard so that you can paste it in for your answer here. How long is it going to take you? It's going to take you, in this box right here, how long is it going to take you? It's going to take you 22.5 minutes to be completely empty. Okay? So now, how you are going to end up today. Okay, so how are we ending class today? On slide 16, 17, 18, 19, you are going to go through and you are going to answer these questions on the slide. These are not in your textbook, so 17, 18, and 19 need to be completed in your textbook. Okay, in your slides, Mr. Main. Boop. Needs to be completed in your slideshow. So you're going to take 5 minutes right now, the last 5 minutes of the day, to go through and look at all 8 questions on 17, 18, and 19, and you're going to answer them in the slideshow. Okay? Awesome job today, guys. So what did we do today? We did 3 things. So in class and this afternoon, we did 3 things. We used technology, mostly this afternoon, to graph linear equations and identify solutions to the equation. So that's the first piece that we did. Then we understood how the coordinates of a point on a graph of a linear equation are related to the equation. We talked about that piece more at the beginning. Then the last piece we did was when given a graph of a linear equation, we're explaining the meaning of the points on the graph in terms of the situation it represents. That is what we did. The last question on each one of those second equations this afternoon. So, ladies and gentlemen, I understand this was a little bit of time, but you guys are fantastic. You worked so hard. Please reach out to me if you have any questions. I will see you all tomorrow. Bye, guys. Oh, code word. Miss Jermaine is a weirdo. She forgot. What is the code word for today? The code word for today is aliens. And if you want to send me an email, you can say, like, do you believe aliens are real or do you believe they're not real? Oh, that's cool. I'm excited. So tell me in your email, do you think aliens are real? Do you think they're not real? Awesome. Okay, ladies and gentlemen, have a fantastic day. I will see you all tomorrow. Bye.